Awesome. So yeah, so this next talk, it will be a bit more of the traditional ML, and it's given by Eason Suen. If you guys have been with us for a while, you'll know that he gave a talk before on reinforcement learning, and today he's going to present his work on decade and analysis of AI research. Eason graduated last year from San Francisco with a major in business. He's worked as a tech investigator and machine learning system developer focused on reinforcement learning systems. He just founded a new company called DenserAI, group that does commercial research and harnesses reinforcement learning and GANs, general adversarial networks, to build demo level products. And one of which is actually a stock market simulator. So yeah, this is Eason now. Are you online? I hope.
Yep. I just want to make sure that if you guys can you guys hear me?
Thank you.
Okay.
Yes, works okay.
Great. So I'm going to share my screen with you guys in just a bit. I hope you guys doing all right, because 2020 has been tough for a lot of people. So I got okay. So I know there's a new IPS going on, so I appreciate that you guys spend time on this. And yeah, it's exciting. Let me see. Okay. So let's start. Let's waste no time. So this is I wouldn't say it's a complete study, because I'll think of it more of a analysis. So this, since we're in 2020, so I think it's good for a good recap, especially this is the last meetup for Hong Kong ML for the year. So I think it's a fitting topic, I would say. So without further ado, let's get started. So this is the agenda for the presentations. It breaks down the presentation very simply. So we're just going to be talking about the objective of the analysis, how do we get the data? And so this analysis has two parts. The two parts both use the same data. So for each part, we're going to explain the methodology, the observations that we made, and the recommendations based on the observations. So just so you know, this analysis is based on two parts. Okay. So let's talk about, first of all, let's give you some backgrounds of this analysis that we did. So this analysis was actually done in a 2-day hackathon in Shenzhen. It was a really fun time. But to give you some backgrounds, the data science hackathon was more about, so when you traditionally when you go to a hackathon, right? In a data science hackathon, you would be given like a training data, and then you build a model and you evaluate that data on test data. You evaluate the model on text data. But this data science hackathon is a little bit different. It's more about evaluating your ability to make a data science decision. It's more about your ability to actually conduct a data science project. So that is the goal that's the intention of the data science hackathon. So there are two takeaways that you can potentially get. One is, of course, the insights that we gathered from the analysis, and also the inspirations that you might get for this study that we did. So again, this analysis has two parts. The first part is about keyword analysis. So we're going to be looking at what are some of the trends for the last 10 years. And part two, it's more about like clustering analysis, which is more about identifying where those research come from and what are their characteristics. So now that I have given you the background, so let's look at the objective of this analysis. We're going to start off with the objective. So it's very simple. The objective is just to visualize the trends of AI research from the last decade, from 2010 to 2020. And we also want to make some recommendations based on those observations. So I think by the end of these presentations, what you can get is, of course, the insights for this analysis and how would you conduct like a similar study in a similar situation. Like you only have 2 days. How do you conduct such study? So that can give you some inspiration. So now that we are clear with the objectives, let's see how do we get the data, right? So archive, if you're in the machine learning world for a long time, you know that archive is a very popular place for researchers to upload their work before they publish their papers. So archive is a place, I think, primarily for STEM. Like if you're in the computer science world, if you're in AI world, then archive is like the to-go place where you can find the research papers that you want. So we use an API to retrieve the papers from January 1st to January 1st of 2020. So that's like exactly 10 years. And we're not gonna, we did not extract all the papers. What we did was just for the abstracts. So we retrieved the papers abstracts, so not like full papers. And once we have those papers, we of course we wanna get rid of the duplicated papers and the non-English papers. There are like, actually, I was surprised that there are so many papers on archive that are not English. Like there are French, Germans, Chinese. So yeah, there are non-English papers on archive. And we also found that there are like a lot of workshop papers on archive, which we of course want them to be excluded. So a couple of things to be noted. Archive has a RESTful API, and we also use another website called Semantic Scholar. This is by, I think, Allen Institute for Artificial Intelligence. It's online, you can search for it. They also have an API where you can get the citations. That's what we use. So we use our archive and Semantic Scholar. So we'll get into that in a bit later when we get to the methodology. So a better way, if you have time, if you're not in a hackathon setting, then it's better to use, Microsoft has an academic graph, which is very comprehensive, very structured. And that is, I think, a true goal for serious researchers who want their work to be published on the journal or something. So that's how we got the data. Now let's get into part one, right? So we have all these papers, all of the informations and the abstracts. So the first thing we want to do is we want to say, what are the top research trends from the last decade? So let's first look at the methodology. So if we want to see the research trends from the last decade, the first part is it's more about keyword analysis. So if you're familiar with NLP, what we're dealing with is the task of keyword extractions. So if you want to extract, this is the question: how do we extract keywords from the food documents? You're going to be doing a series of things. For example, you're going to decap, which is to make sure that the different words are the same regardless of whether or not they're capitalized. And so I think ultimately the goal is to make sure that you don't retrieve some very useless keywords, like the English word the or a or b have no meanings, right? Have no useful meanings. So the first filters that we use is to actually filter out the unmeaningful keywords. So once we have that, we can be reasonably sure that the keywords that we extract will be of meaningful context. So we also count the frequency of those keywords, because we wanna assess their importance, right? So we count the unique frequency. Now there are many ways to do this. The reasons why we chose unique frequencies because we consider the abstract of a paper important enough to say that every word in there is essential. So if for example, if you have a full document, you may have like a lot of repetitive words, then you may want to use relative frequency, which is to count the number of times a word appears in the documents. So So, okay. So can everybody hear me? Because let me see. Okay. Okay. So okay, thank you. Sorry. I don't know what happens, but hopefully you guys are all right. So okay. I don't know if there's a functions where I can actually see the chat. But oh, just do the same thing if I lost the voice, the microphone again. Okay. So the procedures for extracting the keywords is very simple. Because we are counting the unique frequency, all right, we just split the sentence into different words, and then we pick out the unique words, and then we count their occurrences. If they're one of the stop words, then we will exclude the word. So it's very simple. It's if you can see on the slide, this is like a simple codes that you can actually count the unique frequency. It's very, very simple. You just count how many times a unique word has appeared in the abstract. Okay, so that's like the methodology. So let's look at some of the results, some of the observations, right? Oh yeah. Okay, but before that, not observations. Before that, so once we have all those keywords, because we're interested in three things. We're interested in what are some of the problems that researchers have focused on, and their approaches, their matrices. So we sort those keywords into three categories manually. So for example, the keyword accuracy and state of the art imply the same thing. They imply a focus on performance. So we want to manually sort those keywords into three categories. So that cannot be automated because that requires someone who actually is in the field and know what's going on. Like if you're not a machine learning developer, you wouldn't be able to tell the difference between like accuracy or maybe state of the art. So you need some human wisdom in there. So once we finish sorting the keywords into three categories, and then we count them. For example, like you have accuracy and state of the art, we want to make sure that they mean the same thing as we recount those keywords. So that's it. Let's look at some of the observations. So first off, we have discovered like what are some of the popular themes that AI researchers have focused on. There are many ways. I think people often get confused for what like AI is, but in our opinion, the best way to define like a field, a scientific field, is by the problems that it tries to solve. So that's why we're interested. What are some of the problems that AI researchers have worked on? So we have A, B, C, D, E, F. As you can see, you can go through them if you have time when you look at the slides. But basically, they are all the problems that we humans are capable of. That's what AI is. They are the abilities that machines are not capable of, but we humans can do. Like recognizing objects, being able to comprehend things, being able to plan and execute actions. I think what I want to mention here is number E and F, metacognitions and evolutionary traits, because those two things are gaining more momentums in my opinions. Metacognition is about like thinking about thinking. There are a lot more work on this because of the fact that it increases the efficiency of the algorithm. So you can go through them when you have time, but those are the problems that AI researchers have focused on. And those problems happen to be what we humans are capable of. So now let's look at what are some of the approaches that we can use to tackle those problems. So the top approaches in the last decades include this 5 methods. Of course, there are others, but we just picked the top 5. I think they account for the majorities of the work out there in the AI research. So first of all is the learning approach. I think ultimately, there are many solutions to a problem, right? But the way that we think of it is that what makes a approach different is how you see the problem, is how you perceive the problem from the perspective of an engineer or the business persons. So we sort of separate those approaches by the way that they perceive the problem. So you can go through them when you have time, but I can tell you right now, the top two, I would say definitely the learning approach, because machine learning has been so popular, and the search approach is also getting a lot of momentum. So if you have time, I would recommend that you maybe search the works in those frameworks. Of course, there are a lot of overlaps, I would say, but if you want like distinctive approaches, they are the ones. Okay, so let's look at how those approaches positions. So in the last 10 years, from 2010 to the end of 2019, we see that if you see the blue line, the learning curve is going crazy, except the fact that it suffered a drop in 2014. So what you're seeing right now is the rise of machine learning, the rise of deep learning. In the last 10 years, machine learning has been tremendously popular. It almost seems as though AI is completely about machine learning, but it's not. But it has become such a perception that people outside of the community would see. But this is first and most important observations that we see, which is the rise of machine learning. Secondly, we want to see how other approaches are going. So we see the popularity of machine learning, but we're interested in whether or not other approaches are being increasingly integrated into machine learning as well. So for example, now that we are so familiar with machine learning, have we been using a lot of search methods or graphical methods? That's the questions that we want to answer. And the way that we do that is to look at the conditional probability. For example, like what is the probability of search conditions on learning? That's like the definition of conditional probability. So using this method, we count all the keywords again to evaluate this conditional probability, and we do that for every single approach besides the learning. So let's see the results. So on the left hand side, you see that that's the curve that's the graph that you see before. On the right hand side, the bottom right hand side, you see the conditional probability of the other approaches. So for example, you have search conditional on learning. What you can see here is that despite the fact that you have machine learning going crazy, the conditional probabilities are actually quite flat. So what that tells you intuitively is that machine learning has become the true gold methods to solving those AI problems that we talk about, like recognitions, planning and control, and so on and so forth. It has become the true gold. In some sense, it has superseded other approaches. So other approaches have become quite obsolete in a sense. And you can see that in 2014, the conditional probability of Bayesian and learning peaked in 2014. This is because of this paper called auto-encoding variential base. That is the infamous variational autoencoders by two researchers from I think University of Amsterdam. People gave a lot of credit for GAN, but I think variational autoencoder is still like a very impactful paper, because I know the math is so beautiful and it's just so beautiful to me. But yeah, so that's the observation we make, which is that machine learning has largely superseded our approaches used to solve AI problems. So it's not only becoming more popular, it's becoming more exclusive. That might not be good, but we'll get into that later. So we also want to look at what are some of the metrics that researchers have focused on. So what do they value in their work? So let's say if you develop a model, what do you evaluate that model on? You can evaluate the model on performance, efficiency, applicability, so on and so forth. So you have a lot of things. So in this graph, you can see there are a lot of changing components, but what I want you guys to focus on the blue sections, which is the performance. So throughout the last 10 years, researchers have made performance their priority. This has a lot to do with the rise of machine learning. Whether or not there's a cause and effect, we don't know, but there's definitely a strong correlations between machine learning and performance. And if you don't believe me, if you look at 2014, that was the only time that the interest in performance dropped. And if you look at the previous slide, if you remember the previous slides, 2014 was the only time that the interest in machine learning has dropped. So the correlations between performance and machine learning is actually very strong. That's the observations that we make. So if you want to look at what researchers value now, we can look at what's going on in 2019 towards 2020. So you can see in this pie chart that, yeah, researchers still very much focus on performance. And there are also other things, how different their methods are. Of course, if you publish a paper, there's no point in publishing a paper that is exactly the same as others, right? So difference is definitely a big thing. And one thing that I'm very interested in is novelty. So 12% of the research work have focused on novelty. You often, if you read research paper very often, you often see people labeling their work as like novel architecture, novel stuff. So novelty is it's something that I wouldn't expect. And the thing that I want to point out here is that if you look at the bottom 10%, right? Efficiency only takes about 5%. So despite the fact that we have focused so much on performance, efficiency has been largely left behind. So I think that in conclusion, what we see from the last decade is that researchers have focused very much on performance, not so much on efficiency. So I think that would be a problem. So based on these observations, I want to make like 2 recommendations. So first of all, of course, we want to focus more on just research-wise. We want to focus more on integrations. As we have observed before, machine learning has largely become an exclusive method to solving AI problems. That may not be good because you have a lot of money and a lot of effort went into other areas as well, other approaches as well. So you want to see if you can integrate some of those things, some of those resources. I think that's a big thing because when I did this research, when I did this analysis in Shenzhen, I had this. So in the United States, we have a saying that is like, cutting edge AI research is in the United States, but application is in China. When I went to China, I was like, what is China good at in terms of AI? And I realized that there are 2 things. One is scaling. Like the Chinese companies are very good at using very simple algorithm, but they have a lot of data, so they scale very well. And the second thing is integrations. They're very good at integrating different technologies, not just machine learning, not just computer vision, for example, but a lot of things from other areas. So I think if you're researchers or if you're practitioners, you don't necessarily need to invent something new to be successful, to solve a problem. You can think about how can you integrate the existing knowledge and make a solutions that actually work. So integration is a big thing, and efficiency, of course. We know that computing has become harder and harder because the models are getting bigger and bigger, and also the fact that the Moore's law is slowing down. So now is a very good time to really focus on making algorithms more efficient. So that's the 2 recommendations that I would make if you're a researcher, if you're practitioners, or if you're doing a product. Okay, so let's go to part 2. So part 1 is done. Part 1 is about keyword analysis. It's about looking at the trends for the last 10 years and make some recommendations. Right? So here comes part 2. So we want to look at where are some of the where are those influential research comes from. So we're not just looking at like random papers. We are looking at papers that are actually impactful, that are actually influential. So first of all, in terms of methodology, we want to definitely define what makes a paper impactful, right? So the metric that we use is citation per day, which is calculated by subtracting by divided the total citation today from the days it's published. So that gives you a fair sense of how impactful that paper is. So that's the metric, but we cannot use it directly because just imagine this. In the last 10 years, computer vision has been very, very successful, right? If you just count the citation per day, what you end up with is maybe 90% papers that are related to computer visions. But that's just because computer vision has been so popular. That doesn't say that other areas are not influential as well. So what I'm saying is we really need to be fair when we pick the papers, so that we can pick specific papers for specific domains. That's what I'm saying. So this is what we do. So we want to separate those papers into different categories, and then we pick papers for each category respectively. If you're familiar with like US elections, there's like an electoral college where you separate papers by population or by context, and then you pick out certain papers respectively. This ensures that even the papers that are less popular, we have the chance to be selected. Okay, so there are two ways to categorize papers, right? One is the supervised way, which is that you come up with some labels, right? For example, recognitions, machine learning, so you can come up with some labels and you just manually assign those papers to each categories. The benefit of that is how those papers are related, right? There's the unsupervised way, which is that you separate papers by their context, by what they talk about, but you don't care about how they're related. So since we're only interested in like picking out papers fairly, so that it's more objective, we just use option 2, the unsupervised way. So this is what we do. So we wanted to select 100 top papers, right? But we want to be fair. So how do we do that? We use a BERT. I think a lot of you are familiar with BERT already. BERT is a natural language model where you can compute the context of a paper in it's hard to say, but I think a lot of people know BERT already. So it's a way to compute the context vector for each paper. And then once we have the context vector for each paper, we do a clustering to group papers of similar context together. And then we pick papers for each category based on how many papers are there in the categories. So that way we can be fair. So based on this process, this is kind of like a visualization we did. So we use the distill BERT to compute the context vectors, and we cluster the embeddings using k-means clustering. As you can see here, the papers are separated by different colors. That means they're in different categories. And then this visualization is done by reducing the dimensionalities of the embeddings. So we use distill BERT, k-means clustering, and SNE for visualizations. So if you're wondering why we chose those methods, why we chose those solutions, I think because in a hackathon setting, speed is definitely an issue. So we picked those methods because they're fast and not so without actually demonizing the performance. So our primary concern is speed. That's one. I think we spend for 80,000 papers, we spend about half a day. just to compute the context vectors. So half a day, we spend most of the time working on part 2. We spend most of the time computing the context ability. So that's, and you can see there are also some papers that we missed. The benefits about like computing context vectors is the fact that we can see how those papers are related and in an ambiguous sense. So here are some of the papers that we found that are very influential. So we use the metric citation per day, and we got the citation information from Semantic Scholar. They also have an API. You can check it out. So those are the papers that are very influential. They are almost all, like I would say most of them are machine learning papers. You can go through them if you want, but I think what I think the most influential paper out of the last decade is number 1, the AlexNet paper, and people think of it as the ImageNet moment. So in our analysis, the number 1 paper from the last decade is this paper, AlexNet, which signals I think the beginning of a deep learning renaissance. So next. So now that we have all those categories, we want to pick out papers from each categories, right? And then we want to look at their country affiliations. So if you have a research, if you have a work that ties into like MIT, for example, then that counts for the United States. So we just look at what are some of the influential papers and their country affiliations. So this is the results. About 55% of all the influential papers come from the United States. And then you have China, you have Canada, and then France and the UK. One thing to be noted here is that you will see later, but today, most cutting edge research is still done in the United States. And that's based on our observations, but it doesn't tell us what we should do, right? So based on these observations, what we want to do now is to maybe make some recommendations, like, for example, what we can do to actually compete with the United States on the research front. If you're a policymaker, or if you're a C-level, if you're C-level in a company. So what we should do to develop those regional AI strategies. So this is the end of our analysis, but we haven't made the recommendations, right? So we want to use, I personally want to use some outside resources to make my points clear of what I believe to be the way if you want to, build up your AI strategies. So let's look at some similar studies, the results of some similar studies. So this is very this study tracks like just where are some of the elite AI researchers. I can claim myself as AI researchers, but I'm nowhere as good as someone like, I don't know, Clinton, right? So we're just counting on the top 5%. And as you can see, most of them are in the United States. But one thing you can see on this graph is that you have Canada, you have France, but China is nowhere to be found. And I think that's very interesting observations, because we make the observations that China was one of the countries that produces the most influential AI papers. But as you can see, the top researchers are not in China. So we want to see, let's see what's going on here. So let's decompose the AI workforce in the United States. You can see that in this graph, in this pie chart, a lot of the AI researchers working in the United States are actually Chinese. So what that tells you is that there are actually a lot of Chinese working in the United States, and that's one of the reasons why United States is such an innovative center for AI research. You also have India, you also have Europe, but China is almost twice the size of India and Europe in terms of the percentage. So yeah, so you have a lot of Chinese working in the United States in AI. So now here comes the questions. Where are those Chinese AI researchers come from. So let's go into the next graph. So as you can see that a lot of the Chinese PhD students who have studied in the United States actually stay and work there. Only about 10% of the PhD students in the United States return to China. And that's same for a lot of other PhD students, not from China. About over 80% of all the AI PhD students from the United States would choose to stay there. What that tells you is that United States itself is not necessarily very good in terms of talents, but they're very good at, I think United States is very good at keeping the talents in the United States. So that's the observations we're making here. As you can see, this is data coming from Stanford. As you can see that China, the blue line represents the total amount of papers that the Chinese have published. And by 2020, the Chinese have published the most AI papers globally. So by volume, they're the number one. So, but if you look at the next slide, in terms of the number of influential paper, right? The United States is almost twice the size as China. So the Chinese produce a lot of AI papers, but a lot of them are nowhere as influential as the papers in the United States. So what you see here is the evidence, I think, is the evidence of brain drain. I think that's a very universal problem. So the recommendations that I would make here, if you want to be successful, at developing a regional AI strategies, you have a lot of factors, but I think the most important thing is to look at how good you are at preserving your talents, which is say that how good you are at reversing the brain drain against the United States. This comes from some of my experiences as well, because after last year's, I've traveled to a lot of places in Europe, in Asia. I was in India. I was in Shenzhen. One thing that I'm constantly thinking is that if you look at India, right? India has almost the same population as China, and they're also very technologically savvy as well. A lot of CEOs, a lot of the engineers in the United States are Indian. But why is not India succeeding? That has a lot to do with, in my opinion, their inability to preserve their talents, their inability to reverse the brain drain to the United States. That, in my opinion, is the biggest reasons. So if you want to just look at one reason, so if you want to just look at one metric that you can use to develop AI strategies, is to look at how good you are at keeping your talents. And that's my recommendations. And that involves a lot of things, of course. If you're a company, then you may want to have a positive environments. You may want to have a better education for employees. There are many things, but I think if you want to just look at one objective functions, that would be it. And that's it. I think that would be the end of my presentations. And if you want to see a summary of this analysis, you can. I have a link here. Hopefully you can get to see it. But now see if you guys have any questions.
Hey, Eason. Yeah, there's thanks for the talk, by the way. There's one comment from Manuel. Yeah. He says, given how many people participate in the paper, how is the participation of a country apportioned? So how do you divide those?
So what you let me just be clear. So for example, you have a paper that has like international offer. Maybe you have one for the United States, you have one for China. Is that what you're saying? It's like, how do I count how do I count whether that paper belongs to the United States or China?
Yes.
Yeah.
Yes, exactly. Yeah.
Right.
So if that happens, we just count both. That's it. But I would say that was the decisions that we made at the time. But I can tell you that on the top 100 papers, all of them are single country papers. So they're not international collaborations. Yeah. So if that problem came up, we would make the decisions to count them both. But the fact that there's all the top papers are exclusive to one country, then so we didn't have that problem. Yeah, I hope that answers. But you can actually make a lot of decisions. There are definitely ways that you can do differently. I think, in my opinion, right, if I were to do this again, I would say like counting the first offer would probably be a better options. But you make a decision. Okay.
I have seen announcements in China really focusing on applied science rather than pure research.
Yeah.
And I've looked, at least recently, at one particular area, which is smart cities. And I was looking for recent papers and research on that. And really, I would have said 2/3 was coming from China. So is your analysis skewed towards pure research or applied research or some specific domains?
So I would say we didn't start off with that thoughts. So we just purely we didn't expect the results before we do the analysis. Right? We want to make those assumptions, and that's the result that came up. So we didn't say which area do we want to focus on or which country do we want to focus. We didn't have any of that thoughts. So I think that's important too, because I think a lot of data scientists would jump into conclusions before they even start the project. So I think it's important to, even though I'm Chinese, but I'm not, by ethically speaking, I'm Chinese, but I try hard to not like be a Chinese because that would be biased, right? So yeah, I think that's very important, which is that you start off with a questions rather than an answer. But of course the way, if you pay attention to the methodologies, there are a lot of ways in which we really relied on human bias, like how we pick papers, how we decide whether to exclude or include some papers. So there are definitely chances that we we may go with some biases in there. Yeah, I hope that answers. Okay.
Absolutely, thank you.
Thank you. Okay. Let me see. We have a question from Vincent for dimensional reductions clustering. Oh, that's not really a question, but yeah. If you look at the track, I definitely agree with Vincent. We have a new method called UMAP. It's much faster. I would say it's much easier as well. But I think the reason why we chose the SNE was because it was like our true goal methods. Everybody knows the method. Not everybody knows the UMAP. So that was just the consensus that we make. Yeah. I think that's it. So any more questions?
Do you intend to renew that analysis in a few years? Or?
Okay, so let me put it this way. So we thought that we were gonna win with that analysis, but we didn't win. I think there are many reasons. One is because my Chinese kind of suck when it comes to presentations, but another reason is because I think the level was quite high. The reasons why they didn't ask us is because we're in 2020, and that's the end of the year. We think it's a good finish analysis on many things. So maybe, I don't know, maybe we'll wait for the next 10 years and see. But the thing is that we definitely need a lot of data to make this kind of generalizations, right? So I don't want to do similar things without enough data. Yeah.
There has been, at least in the past, let's say 3 months, changes in the Chinese regulations that basically, if you want to export an AI model out of China, you need to get an approval, which is a big headache for a lot of companies, obviously. But
I heard that as well.
it is, unfortunately, I know specific examples where people really, really struggle with that. So in a sense, does it mean that it becomes harder to capture exactly what research is being done?
In China,
Yes.
I tell you what, there are China has a lot of advantages when it comes to research that United States or the Western countries like France or Germany don't. Now, one thing is very important, which is that if you have a research paper in the United States that just came out, I would say in 24 hours, the paper is translated into Chinese. The same is not for the United States. So if you have a Chinese paper that came out, unless it's written in English, unless it's published in a journal, you're not gonna get the advantage. So the Chinese have a very developed infrastructures for scientific research. And that's very exclusive as well. I think that aligns with the Chinese strategy as well, which is that they want to focus, I think especially now in the next 5 years, they want to focus more on internal consumptions, which is the fact that, hey, if you want to get some of the benefits that we are making, come to China. If you want to get some of the market, some of the consumptions that you want, come to China. So a lot of things, yes, are not fair to the West, because but I think that also accounts for the fact that the West is not doing enough to understand China and their research and their work. This is what I think. I was fully educated in the United States, but I think being in China is a completely different experience where it changes a lot of your perspectives. So I would definitely say that, yeah, it's becoming harder for AI research, but I also think that the West is not doing enough to understand China and their research and how they do things and their reasoning. Yeah, I would say that would be maybe a different perspective on things.
Yeah, no, it's absolutely true that there is very little understanding from the West, very generally speaking, as to what China is inside. But at the same time, likewise, China probably has misconceptions or mistrust about the West, and that will take generations probably to sort out.
Yeah, hopefully. Because I think for AI in general, for the field in general, like we always want inclusiveness because it's such a impactful technologies that we've been working on. So I encourage inclusiveness, but that also requires that we really get to know each other, not just saying like, hey, open up, but we really need to like speak the language and get to know them on a human level, maybe. But yeah, thank you for that question. I think that's such a good point.
It's interesting because you just said language, but if you think about it, over the past maybe 10, 15 years, open source has become so critical, and anybody who enters the field nowadays expects code to be shared, data to be shared, and in a sense, programming languages and the source of the code, that language, has become a way to understand each other.
Yeah. Yeah, because especially I think in software world, it's definitely that there's so much emphasis on, like, the reason why arXiv is so popular is because of the open source spirits, right? Before you had to pay so much money to get to read a paper. arXiv has become, I think, it's now you basically can read all the papers for free. That has never happened before. So I think that's good. But the thing is that just imagine this, right? If you think that open source is that good, why are there different languages, like programming languages? Why are there different like cultures? So in my personal opinion, right? We of course want to focus on open source. We want to speak the same language, but we also want to preserve a lot of the quirkiness that that our regional characteristics have. Like one thing about China that the United States doesn't have is the size of the STEM populations. So, for example, my brother works in Shenzhen. He's a machine learning engineer as well. He has focused on a very outcasted, I would say, a very unconventional area of machine learning. That is not possible if you just have a very small STEM populations, because you cannot have any brain if you don't have any talents to focus on those less invested areas. So if we all speak the same language, then of course, then what happens is that you lose diversity, right? My personal opinion is that we should encourage like inclusiveness, but that comes with the price that we have to increase diversity as well. That means that we have to try to understand each other, like what they do and how they do, but without the thinking that, oh, open source is the best, so we have to open source everything, because that would lose the diversity that we should expect. Okay, anyway, any more points for an interview?
Cool. Maybe not. Well, thank you, Eason. And where can people find you if they want to reach you?
I think just find me on LinkedIn. I'm not on LinkedIn much, but if you have important things, I would definitely reply on them.
Awesome. Sounds good. Thanks a lot, Eason. Thanks everyone for coming.
Thank you.
And yeah, I think this is the last one of the season. Have a good Christmas. Happy New Year.
Yeah, thank you for joining, everyone.
Good night, everyone.
Yeah, have a good one, everyone.
Bye.
Thank you, everybody.